Hello class, welcome to lesson 4.2. Today we're going to discuss isosceles and equilateral triangles. So for today, our essential question we want to address: how are the side lengths and angle measures related in isosceles triangles and equilateral triangles? So how are those two related for those two sets of triangles? And so today we're going to apply theorems about isosceles and equilateral triangles to solve problems. So for today, we want to discuss the following vocab terms. So we want to know what a base angle is, the base of a triangle, equilateral, angular triangles, isosceles triangles, what a leg of a triangle is, vertex angle, and vertex point. So let's discuss isosceles triangles first. An isosceles triangle is a triangle that has two sides that are the same length. So in the triangle below, notice that we're using the symbol here indicating that those two sides are congruent and they're the same length. And so this is an isosceles triangle. So these two sides are referred to as the length. The bottom side here is referred to as the base. So essentially, the base of a triangle is the part of the triangle in which when you extend from the base to the vertex, which is the other corner, that becomes the altitude. Okay, so and then the base angles are the angles that are formed at the base of the triangle. Okay, so as we said, that the base of a triangle is such that if you were to draw a line to the opposite corner, which we call that corner a vertex, and let's go ahead and draw this a little bit better here. So let's say this is our triangle. We're drawing this is called like an altitude or a height. So this is like our altitude or height. So it's such that if you were to draw this height to the opposite vertex, the opposite corner or vertex point, then that will be the height of the triangle. Okay, so that's how you define the height of a triangle and the base. And so you can rotate this triangle any which way you want, and then you would have a new height. So if I were to make this the base, then I would have to obviously essentially like rotate the triangle. And so now this is this which used to be my leg is now my base, but then I extend it. I would extend it to the opposite corner here, right, at a 90-degree angle. It has to be at a 90-degree angle. And that will be the height of my triangle in this example. Okay, so the base depends on how, which one is the height. Okay, so the height and base are interrelated. Okay, so and then this little corner here, which is the angle at this vertex point, is known as the vertex angle. So the isosceles triangle theorem states that if you have an isosceles triangle, which means that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So in this example, we have an isosceles triangle, triangle ABC, and we clearly can tell from this diagram that AB is congruent to BC. So this is congruent to this. And therefore, we know that these two angles have to be congruent as well. And the converse, so we can actually reverse this statement. Remember that the converse is the reverse of the statement. So it's when you reverse the original statement. So now if you reverse the statement above, it would state that if the angles are congruent in an isosceles triangle, then the sides opposite those angles are also congruent. So if you have a triangle and you want to determine, well, is it isosceles? Well, if these two angles right here are congruent, well, that means that these two sides opposite of each, right, opposite of each of the angles are also congruent, which means that this is indeed an isosceles triangle. Okay, so this states that if angle ACB is congruent to BAC, then that means AB has to be congruent to BC. So let's look at an example utilizing this theorem. So we want to find all of the missing angle measures for each isosceles triangle. So let's take a look at the first one here. So We can tell that this is an isosceles triangle because of the congruent tick marks here. So we know that those two sides are indeed congruent. And so we need to figure out, well, what's the other angle? What are the angles for this triangle? Well, because these two sides are congruent by that other theorem that we just mentioned, right? The isosceles triangle, that one theorem. Well then, since this is 51 degrees, well, that means that this has to be also 51 degrees. And so those two angles are indeed congruent, the ones that are opposite of the sides that are congruent. Okay, so we know that they're both 51 degrees. And so we can say with confidence that for part A, the measure of angle, we'll call this QPR, is equal to 51 degrees, which is the same as angle QRP. And so now let's figure out what angle PQR is. Well, remember that the angles in a triangle add up to 180. That was the triangle angle sum theorem, right? So we can figure out what this angle is if we add up these two other angles. So we know that we have 51 plus whatever this is, we can call it x if we like, has to equal 180 degrees. And so we can find angle Q or PQR this way. So 51 plus 51, that's 122. And then, then we subtract both sides by 122. And so we get the missing side. And the missing side is 58 degrees. And so now we know that the measure of angle PQR is 58 degrees. All right, so let's take a look at the other one. So for triangle DEF, we know that it's an isosceles triangle because of these two congruent marks. And this time we know that this is 77 degrees. So we know the vertex angle, but we don't know the base angles. Okay, so when you're looking at an isosceles triangle, usually the base is usually the side of the triangle. Usually, it's the side of the triangle that is opposite of, well, it's usually the side of the triangle that has the base, that has these angles here that are opposite of the congruent sides, okay, or the congruent legs. Okay, so here we have two congruent legs, and so usually the base of an isosceles triangle is usually, you know, that side that has the angles that are congruent. And so we know that these two angles have to be congruent because these opposite legs are congruent by that theorem. And so if this is x, well, then this is also x, right? So whatever this is has to be the same as whatever the other angle is. And let's use another color there. So let's say this is x, well, then this also has to be x. And so if we were to add up all the angles in this triangle, they would have to add up to 180 degrees, right? So we have x plus x, because those two have to be the same angle, plus 77 degrees is equal to 180. So now we can go ahead and combine our like terms. So this is going to give us 2x. Then we subtract 77 on both sides. So we're left with 2x equals 103. Then we can go ahead and divide by 2 on both sides. So we have a rather odd angle. So it's going to be 103 divided by 2. We can figure out what that is. We'll do that off to the side here. So we know that 100 divided by 2 is 50. And then 3 divided by 2 is 1.5. So we could just say that this is 51.5 degrees. And so we know that from this information, then that means that the measure of angle EDF, which is the same as the measure of angle DFE, is equal to 51.5 degrees. Okay, so let's look at in here another example. So find all the missing angle measures for each isosceles triangle. So this one's different because there's variables involved, but it's still the same theorem. Okay, it's still the same idea. So we have an isosceles triangle here, and we know that because these two sides are the same, this means that these two angles are the same, right? So this is 28, and then this is also 28. And then we also know that these three angles have to add up to 180. And so I have 5x plus 9, that first angle on top, plus we have 2 28s, has to equal 180. And so I can go ahead and combine my like terms, 28 plus 58 plus 9, or 28 plus 28 plus 9. So we have 56 plus 9. So that's going to be 65. Then we have 5x plus 65 equals 180. We'll subtract 65 on both sides. So we have 5x equals 115. We can divide by 5 on both sides, and we get x. And so we have x equals, so 5 goes into 115, 5 goes into 11 twice, so it'd be about 23. So x is about 23. So because x is 23, remember they want us to find all the missing angles. So x is not an angle, x is just a variable. So we're going to plug that in here to get that angle. All right, so let's do that over here. And this is angle 8. So we know that this angle here is angle AB or BA or ABC. So that's going to be the measure of angle ABC is equal to, then we go ahead and we plug into that. So that's 5 times x plus 9. So 5 times 23, this is where we plug in for x, plus 9. 5 times 23, it's going to be 115 plus 9. 115 plus 9 is 124. So it's 124 degrees. All right, so let's go ahead and do the same for part B. So for part B, we have, again, these two are congruent, which means that these two angles have to be the same. Because those two angles have to be the same, well then that means that we can set them equal to each other. And there you go, there's my equation. Those two angles have to be equal to each other because those two sides opposite of them were equal. And so we can go ahead and solve this now. So we have, let's go ahead and add 4x to both sides. Just to kind of move the x to the other side. We have 9 equals 12x minus 3. Then we'll go ahead and add 3 to both sides to get x by itself on the right side. And then we'll divide by 12 on both sides. So 12 divided by 12 is 1. So 1 equals 1x, or x equals 1. So now we know x is 1. We can plug in 1 into there and there. And that will give us angle, that'll give us angle yxz, right? So let's go ahead and do that for yxz. So the measure of angle yxz equals -4 times x, which is 1, plus 9. And then, so this is just going to be -4 plus 9, which is 5. So this is going to be 5 degrees. So pretty small. And then, well, because we know that this is 5 degrees, well, then we know that this other angle is also 5 degrees, right? So really small. And so we know that the other one, 8x minus 3, is also going to be 5 degrees. So we have the measure of angle yzx is also going to be 5 degrees. And so now we know that those two angles are 5 degrees. Well, then remember, if both of these are 5 degrees, so let's cross this out now. So let's cross this out and say that's 5 degrees. That's 5 degrees. Well, then this angle has to add up to, these three angles have to add up to 180, right? So we have 5 plus this unknown angle, which we'll call y. I'll call it y because we had x already, equals 180. So 5 plus 5 is 10. So 10 plus what is 180? Well, it's going to be 170. So this here has to be 170 degrees. And so now we can say with confidence the angle XYZ is 170 degrees. And those are my three angles. All right, so now let's look at another theorem for isosceles triangles. This is not an official name by any means. This is just something that this is just a name that I call it. So I call it the isosceles triangle bisector theorem. So if a line or a line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. So let's break that down and figure out what that's saying. So that's saying it's saying if a line segment bisects means cuts in half. And we're talking about the vertex angle. So what's that? Well, the vertex angle, remember, is in a triangle. This top part is what we call the vertex, and this is my vertex angle. So it's saying that if I cut that vertex angle, so in this diagram is that's your vertex angle. If I cut that in half, so this means cuts in half, then that means that this is also the perpendicular bisector. Perpendicular means 90 degrees, remember. Bisector means cuts in half. So this is something that cuts this other side in half. So it's going to cut this in half, which is how you get this other diagram, okay? So basically, if you were to take a line and you bring it straight down from the vertex angle, well, then that line is going to cut this in half, and it's going to cut the angle in half, and it's going to cut the base in this case, because this is the base, this bottom part, in half. Okay, so that's referred to as the isosceles triangle bisector theorem. This is what I call it. Okay, so let's go ahead and use this theorem in the following example. So we have an isosceles triangle. We know because of these two sides are the same. What is the measure of angle RSQ? So we want to figure out RSQ. So we want to figure that out. Well, first off, we know that if this is the base, why do I call this the base? Because these two sides have to be the same, because these two angles have to be the same, because they're directly opposite of these two angles. Okay, so therefore I'm going to call that top side the base, and these will be called the legs. Okay, so this is leg 1, this is leg 2 of the triangle, and these two legs are the same. Well, by that first theorem, we know that these two angles have to be the same, right? 31 degrees here, 31 degrees there. And also by the theorem that we just described, the isosceles bisector theorem, well, this actually cuts this angle in half. So this is the vertex angle, and this line has cut this angle in half. How do I know that? Well, because they're saying that this is equal to that, because they're using the marks there. So those symbols that they use there, those arcs, they actually indicate that they're the same. All right, so those two angles are the same, which means that this bisect that angle, which means that this is going to be a perpendicular bisector, which means that this is actually a 90-degree angle. And so we already automatically know what that question mark is. That question mark is 90 degrees. So by that theorem, we know that RSQ has to be 90 degrees, has to be a right angle. All right, so that takes care of the mystery of that angle. So it's 90 degrees, and that means that these two sides are identical, those two halves that this cut into. So then what is PR? Well, we know that QR is 4, right? But because based off of this information, but since those two sides are the same, well, then that means that this is 4. And so that means PR, the distance from P to R, is 4 plus 4, which is 8. So PR is equal to PQ plus QR, that's the segment addition postulate, if you remember, which is 4 plus 4, which is 8. All right. So let's look at, so we looked at earlier the isosceles triangle. So now this time we're going to focus on the equilateral triangle. So an equilateral triangle has the same length for all three sides. Equal meaning equal, and lateral meaning side. So kind of like in football or in a sport, or just in general, the term lateral means side. If you do a lateral pass, that means you're doing a pass to the side, to someone beside you. Okay, so equilateral means same side triangle. So an equilateral triangle has the same length for all three sides. And because all three sides have the same length, well, then that means that all three angles have to have the same measure. And that's because if these two are the same, well, then by that isosceles triangle theorem that we mentioned in the beginning, that means these two opposite angles are the same. And similarly, if these two opposite ones are the same, then that means that this has to be the same too. And so all the angles are identical. And remember that because there are only three angles in a triangle, and they're all the same, well, then that means that if they're all the same, well, then they're all x, right? So let's call them all x. So x plus x plus x has to be 180 degrees. Remember, all the angles in a triangle have to add up to 180. Well, then there you go. So that means that 3x is 180, which means that if you were to cut a 180 by 3, well, then that means that each angle is going to be 60 degrees. So an equilateral triangle has all the angles being 60 degrees. All right, so an equilateral triangle is also known as an equiangular triangle because the same angle. So equilateral or equiangular, those are in this case synonymous. All right, so let's look at the final example. So this example uses some equilateral triangles. There also seems to be some isosceles triangles thrown in the mix. So we're kind of combining them. So looking at part A, we see that we have an equilateral triangle ABC. We have an isosceles triangle ABD. And they're saying if CBD is 130, so that means CBD, that means this here is 130. Then what is BAD? So BAD, so they're looking for that. So that's the question mark here. Well, first off, we know that that these angles in the equilateral triangle have to these angles in an equilateral triangle are all 60 degrees, right? So I know that this part of this angle is 60 degrees, and this part is 60 degrees, and this is 60 degrees, because that's an equilateral triangle or an equiangular triangle. And so that entire angle that's worth 130, well, that means that this part has to be 130 minus 60, right? Because if those two angles have to add up to 130, well, then, you have to subtract, and that'll give you the other angle. So now we know that this other angle is 70 degrees. So now I'm going to go ahead and replace this with 70 degrees just for this blue part. So now I know now that this blue part is 70. And so what is this red part? What is this question mark? Well, we know that for this triangle, so this right here is my isosceles triangle. And these two sides are the same, which means that this question mark angle and this question mark angle are also the same. So let's call that question mark angle x. So we have two of the same value, so they're just called x, and we have 70 degrees. Well, we can find this because this is a triangle after all, and a triangle, the angles of a triangle have to add up to 180. So we have x plus that blue 70 has to equal 180. And so we have here 2x plus 70 is 180. We can subtract 70 on both sides and solve for x here. So 2x equals 110. We'll divide both sides by 2. And so x, which is the question mark, right? That's what we're looking for in this example, is 55 degrees. And so the measure of angle BAD is 55 degrees. All right, so let's take a look at the second problem. So what is the measure of angle U? So they're looking for this one. So this is the unknown. Well, so we know that we have an isosceles triangle on this right side. And we also have another isosceles triangle. Funnily enough, we have another isosceles triangle on the left side. So we have two isosceles triangles put together back to back here. So no equilateral triangles, surprisingly. So we know that since this is 72, so this is the vertex angle, 72 degrees. But because these two sides are the same, the angles opposite them, which is this angle and this angle, those two angles have to be the same as well by the isosceles, angle theorem here. And so because they're the same, let's go ahead and call them x. And then we can figure out what those are. So let's go ahead and figure out what those are, because that'll help us. That'll probably help us what we have on the other side. Okay, so we have x plus 72, because that's a triangle, has to add up to 180. So we have 2x plus 72 equals 180. We'll go ahead and subtract 72 on both sides. This will give us 108, and we'll cut that in half. We get x equals 54 degrees. All right, so we know now that these are 54 degrees. So this is 54 degrees, and that's 54 degrees. All right, so now we have here on this right side, we have an isosceles triangle there. So, and because these two are the same, that means that this angle, which is opposite of this blue side, right? That's opposite of that, is equal to this angle, which is opposite of that, right? Of that side. Okay, so that means those two blue angles are the same. So let's call them x. Well, let's call them y. Let's use another variable, right? So y, let's call them both y. And then what is this other angle? So what is this green angle? Well, we know that 54 and this green angle actually add up to 180 degrees. So if you notice, these are actually form a linear pair. So this red angle, this green angle, actually add up to a half circle. You notice that the green and the red form a half circle. Well, a half circle is 180 degrees. And so we can find this angle by doing 180 minus the 54 degrees. And so 180 minus 54, that's going to be 126 degrees. So we have 126 degrees for that green angle, and then we can figure out the blue. So remember that the three angles in a triangle add up to 180. So we have here 126, the green angle, plus y plus another y equals 180. So we have 126 plus 2y, and then we can proceed to solve this. So we're going to need some room here. All right, that's better. So let's subtract 126 on both sides. So we have 54 degrees, divide that by 2. So y is 27 degrees. Okay, so let's go ahead and see what we're looking for. So y happens to be exactly what we're looking for. So y is 54 degrees, which means that the measure of angle U is 54 degrees. All right, guys, that's going to do it for the lesson. I hope you took a few things from this lesson. You learned a few things. And as usual, I'll see you in the next one.